we're going to do a change in sorry, I lost my stylus. So we just did concentration, so then let's do a change in temperature. So temperature change. All right, so with our reactions, they have there's two reactions with temperature, right? It's either exothermic or endothermic. And essentially what that means is that if your reaction is exothermic, your delta H is going to be negative, right? And it also means that heat can be considered a product. Because in an exothermic reaction, you're releasing heat, so you're creating heat, therefore heat is a product. And then in an endothermic reaction, your delta H would be positive, and therefore heat would be a reactant. Because essentially in an endothermic reaction, you need heat to cause that reaction, right? Like it needs to start with heat. Okay. Right. So because heat is considered a product, if we were to, say, increase the temperature, so temp increase, then we're increasing our products, right? So therefore, we would have a shift to the left towards our reactants. And same thing over here. So if we have a temperature, or like vice versa, a temperature increase here, and our heat is a reactant, and that means we're making more reactants, so therefore we would have a shift to the right towards our products. So, oh my god, I keep forgetting to turn on my eraser, and that's on me. So yeah. So then, same thing as I said, if we're going to be considering heat as a product, if our temperature is decreasing, then that means that our product is decreasing, so therefore it would be a shift to the right towards our product, and vice versa over here. If our temperature is decreasing, then that means that our reactant is decreasing, so it would be a shift to the left towards our reactants, right? So then keep that in mind. So hopefully you guys are writing this down because I'm about to erase it so that we can do some examples. Right, so again, generic equation, A plus B yields C plus D. And let's say that this has an enthalpy of 87 kilojoules. And then we have a temperature increase. Right, so we see right here that our delta H is positive, right? So therefore, it's endo. Oh my god, that got really crooked, I'm sorry. So yeah, this is positive, so it's an endothermic reaction, correct? And since our temperature is increasing, and an endothermic reaction means that we can pretend, or more like say, that heat is a reactant, and we're increasing our heat, right? So then therefore we would have a shift to the right. So yeah, like I said, this isn't too bad. It's just a lot of rules for the Chateliers principle. So then let's go another way and say that, sorry, I'm trying to adjust this, but there we go, close enough. But okay, so then now let's say that our reaction is exothermic and our temperature is going from 65 degrees Celsius to 35 degrees Celsius. So if it's exothermic, heat is a product, right? Okay, but now looking here, is our temperature being increased or decreased? It's being decreased, right? Because we're going from a bigger number to a smaller one. I forgot my Celsius. So then heat is being decreased, so then therefore we would shift to the right towards our products, because like I said, we're getting rid of it, so we need to make more of our products to fix that gap kind of that we're creating. Right, so now for the last thing, it's essentially we're going to do pressure and volume together because they relate to each other inversely. So it's kind of like if you guys remember your PV equals and nope, I'm thinking of something else entirely. My bad. Ignore that. But okay, as I was saying, they're related to each other inversely because essentially if you have a closed container and you were to lower the volume in it, your pressure would increase because now your gas essentially has less room to move around, right? So yeah, that's why we do pressure and volume together. So essentially what this is that if your pressure increases, your volume decreases. And with these, it's not a shift to the left or to the right, it would be a shift to the least moles. And then vice versa, so if pressure were to decrease and volume were to increase, then you would shift, I forgot the T, okay, shift to the side with the most moles. Which, okay, I know they're written together, but your problem can give you a volume decrease, and you would still shift to the side to the least moles, just as if it were to just say pressure increase, you would still go to the least moles, and so forth. So, just kind of a like, how do I say this? In shorthand, essentially, so that you're not writing everything down, or like you're not just confused. It would be like pressure increase equals least moles, pressure decrease equals most moles. Volume decrease equals least moles. And volume increase equals most moles. So then, since this isn't taking up as much room as the other ones, we can do an example problem down here with your rules still written up here. So then, like I said, generic gas formula, because it's pressure, that only applies to gases. To be yields, let's say 3C plus D, gas. So then if I were to say that this is all happening inside of a piston, and then out of nowhere our volume is halved. So if our volume is halved, that means that our volume is decreasing, right? So we would have to go to the side with the least moles. And the way that we calculate moles is by adding up our coefficients. So on our reactant side, our moles are 3 plus 2, which is 5. And on our product side, we have 3 plus 1, which is 4. So in this case, 4 is less than 5. So we would shift to the right. Right? So there we go. Not that rough. It's just make sure that if you're given a problem, that everything is balanced, because or else you're going to screw up your mole calculation. So then, cool, let me change that real quick to a solid, just because. So then let's say that our volume, okay, so our volume is still halved. So now if we're calculating our moles, on this side it's still 2 plus 3, which is 5. Okay, no, because we're going to get something else. So instead of halved, let's go that it's being increased. Which if it's increased, it goes to the most moles, right? Which, yeah, we still have the same thing. But anyway, products, in this case now, it's just going to be 1. Because I changed this to a solid. And like I said before, solids, liquids don't matter for equilibrium. So 5 is obviously bigger than 1. So then because I changed it to increased, we would shift to the left. Oh my god, see what I mean by I don't know my left or my right? But yeah, we would shift to the left now because this has the most moles. And then if in this exact same question I were to say what's happening to our pressure, so since our volume is being increased, that would mean that our pressure is being decreased. And yeah, that's pretty much it for Le Chatelier's principle.